I feel a little bad, but not terribly bad because, here it just, okay, this was number 2. Number 2, pause the video. Sorry. This is number 5? 5? Yeah, sure. And this is number 3. Pause the video if you want to look at it closely. There we go. Okay, so now I want to just type this in. So I just want to see that I get it right because it's fun to get the right answer. So we have n plus 1 over 3 to the n. Oop, why do I have so many parentheses? I don't know. And then times x to the n. Like me. Let me see how they wrote it. Oh, almost the same. Very good. All right, so what other issues do we have? Did this help? Did this figure it out? You got it now? Yeah, Jackson. Yep, we can do every one of these if we need to. It's the day before a test, so I'm super liberal about what we do. Do it all if we need to. Oh, look, and there's this one sad thing, a message that I didn't read. I apologize if that was you. Okay, yeah, let's do this one. Write this as a rational function. Ah, very good. This is good to review. Okay. Wait a minute. Interesting. Yeah, that one is different. Fascinating. Why did I choose that? I don't know. That's really interesting. Yeah?
My numbers are a lot more interesting.
Then this one? This one's it. Okay, let's hear yours, Jackson. If you want to brag about yours, go ahead.
All right, it's 1 over quantity x minus 6 to the power 2n minus 1.
Wow. So I got this super simple one for question 1, and you got something super hard?
Yeah.
Amazing. Okay, well, let's see if we can work out Jackson's version then. And this is, I'm assuming you're going from 0 to infinity? 1 to infinity? Why do they do this to me? Okay, yeah, that's much more interesting, I'd say, than what I have. Oh, mine goes from 1 to infinity as well.
Because you put 0 and it's not
No, it's not. 1 over 1 is, x to the 0 is 1. Yeah, that's all right. That's all right. I can handle the n equals 1. It's going to be okay. Okay, so let's see. Oh, this is good. This is good. Thank you for bringing this joy to my heart. So, first things first, in order to do this, what I'm going to want to do is I need to make this look like something that I can do. I can do this. In fact, Jackson, you can do that one. In fact, what is the function, like, what is the sum of r to the n? What's the formula for geometric series? 1 minus, well, I've got an r here, so x, r, whatever. Actually, this is, I'd have to have n equals 0 to infinity for this to be true. So here's what I do with any series like this where I'm asked to do something like this, is I want to take what I have and manipulate it until it looks like this. Okay, so here's the manipulations as I see them. So the first thing that I'm going to do is, I don't like that 2n minus 1 there. Yeah, this is way harder than the one that I had. So anyway, way more interesting, I should say. So n equals 1 to infinity. And so here's how I'm going to do this, is I'm going to rewrite this like this. Factor out one of the x minus 6's. Don't worry. And when I get done with this, it's going to look like that. I know you don't believe me, but it will. Okay, so I'm going to do, it's all algebra. We're doing a bunch of algebra. Okay, so there's my first move. Is that right? Oh, 2n minus 1, crud. Okay, just a minute. Yes, let me fix this. Sorry, I was a little overzealous. Let me just fix this really quick. Sorry. Okay, 2n minus 1, here's how that shakes out, right? Like a 2n minus 1, it means that there needs to be one of them on the other side of the bar here. But if you combine these, you do get this. So just a little bit of algebra. Okay, the next thing, still more algebra. Which one do I want to do first? I'll do this first. X minus 6 times this summation. Okay, I'll explain, don't worry, because I know some of you are losing your minds at this point. So all I did there is I recognized that this is a summation, and this does not have in it, so I can factor that out. Since this is part of every term in this summation, I can move it outside the summation and put it there. So that's okay, simple, I'll do simple steps, bite-sized chunks. Okay, the next thing that I'm going to do is also basic algebra. Well, I don't know if I'd call it basic, but it's algebra. So this is going to look like this. Technically, I just did 2 steps there. I wrote this as x minus 6 squared to the nth power in the denominator, and then I just said, well, since there's just a 1 up there, I can write that as a single fraction as 1 over this. But you can do the math and verify that that's correct. Even if it's hard to do what I just did, you can certainly go the other direction to verify that what I did is correct. Now, sadly, that is still not good enough. And the main reason it's not good enough is because of this down here. That starts at 0. This one starts at 1. But we can fix this. So here's how I'm going to fix it. Is I'm going to stop what I'm doing, and then I'm just going to write this. So I know it looks like I'm just pulling this out of thin air, but here's the reason why I did it this way. And there's that nice little wavy line saying that this is something different. I'll come back to that in a minute. But I needed this to look like that. So I need the 0 down there. And I think you can probably see now that this is R. Here, let me highlight. So we have the n equals 0, which is what we wanted. I'm going to highlight this. That is taking the place of R in the formula. And so I could just take this and rewrite it as 1 over 1 minus R. So here again, let me just highlight. This is R, which is the same as this R up here. So I know it's kind of a pain. You know what I'm going to do? I'm going to move that. I'm going to move this up here, just so that we can have them next to each other. There we go. Now you can see that all I did, compare this with this, is this has this nasty thing instead of R. Otherwise, it's exactly the same. Okay, now we have to deal with the fact that that starts at 0, whereas this one starts at 1. Well, if you think about it, what you could do is you could just take this the 0 term. The only thing missing from this one down here is the term where n equals 0. Oh no, what just happened? What just happened? Oh, it went back, it bounced back. I don't know why it went back down there. I got scared that I lost it. There, it's still there. Okay, so the only difference with this is, so here, I'll even write this out, is if I do this, n equals 1 to infinity of 1 over x minus 6 squared to the n plus 1 will equal this. That is to say that the only thing missing from the whole series over here is the n equals 0 term, and this is the n equals 0 term. Probably I should put that out front. In fact, I'm going to. I don't like that there. How about that? So there. Okay, so getting back to, oh, and then let me just point out that if you subtract 1 from both sides of this equation, you'll get the expression for what we're really interested in. Because what we're really interested in is this thing here, and that thing will be this thing minus 1. So just put a minus 1 next to this. Okay, so let's do that. So now I guess I don't need my wavy line. So here's how this is going to look. I have x minus 6 times the quantity of 1 over 1 minus the common ratio, 1 over x minus 6 squared. Sorry. Minus 1. And that's it. That'll do it. I mean, it would be really nice if I simplified that, but now you've got a different problem than I do. So, yeah, mine is far simpler. Well, you know what? Let's see if I can doctor it up. Let's see if I can just do this. Since I have x, not x minus 6, can I just do this? X times, so I'm just going to change all of the x minus 6's to x's. So x times, I'm just curious to see if it'll accept this really unwieldy fraction here. 1 minus another fraction, 1 over another parenthesis, x to the second power. It should be the same. Okay, this is going to be minus 1. So you put, let's see. Oh, it did like it. Wow. So if you do the same thing that I just did, but with x minus 6, oh, wait a minute. You had a completely different, you had 2 in, I get the same answer. That's so weird. I don't understand now, because, sorry, I'm going to have to examine this later, but you had a different exponent than I had, and yet that form of the answer still worked. That's so weird. I'll have to think about that at another time, but right now, let's see. This is, if you simplified it, that's what you get. And I'm sure that if you simplified this nasty thing, you would get something that was simpler. Austin?
Does it completely simplify to 1 or something like that?
This one?
It accepts 1 for all different forms of it. Just 1 and 6, right?
Really?
Yeah.
Wait a minute. Will it do it for mine? One? Why is it not
I think it's like a button manual.
submit? Why?
Does it just take anything?
Wait a minute. I'm so curious. Let's just type X in. Oh, this one's broken. Oh, that's boring. It's broken. It doesn't work. Oh, that one didn't like it. Okay. It's so curious. X minus 19. Unbelievable. It's clearly a broken file. It's not working. I need some help. Let me message my instructor on this one. Okay. So apparently you can get it, but that's not right. This is right here. So apparently you can just type in whatever you want, as long as it has an X in it, or a number. Probably put number 5. Put your age. That's irritating. Okay, so now that solves the mystery as to why my answer that I typed in for where it was just the simple version, it was wrong, but it thought it was right. Okay, is there anything else, or are we done with this? Sorry. Here, let's see, let me go back just a minute. Can I back up? Here we go, questions. Okay, so is there anything else that oh, wait, what does this say? Not, what's this? It's a problem though. There's a problem with this. Oh, wait, no, not this one. Which one did we just do?
Number one.
Oh, it's number one. Okay, here. I'm going to do this. Change code, withdraw, restore, edit personal copy. I thought there was a place where I could complain. Maybe if I click this, can I complain? Just a minute. There should be a feedback place for me. Where's my report question bug? Okay. Okay, here we go. This accepts incorrect answers. Any answer that is a function of x. Done. Okay, I feel better about myself now. I've complained. Okay, what else do we need to deal with? Are we done? No, we're done because we need to do quiz. Do we need to do quiz? No, what we need to do is I need to talk about the test, and then if we have time, we do quiz, because you're worried about the test, I can tell. So give me a sec here. I thought I had this up here. Where is it? Oh, I know where it is. It's right here. Okay, so I need to give you a couple instructions. If we have time for the quiz, great. If not, I can just give it to you for fun, because it's fun. I don't know if it's fun or not. But here's what you need to know is I have on our webpage, I have had for the past week, I believe, that file has been there. And then this morning, these two additional things have popped up. First of all is the practice exam with alleged answers. They're the ones I hope are correct, but I might have made mistakes, because I am prone to mistake just as easily as you could make a mistake. So, but if you click on that, you'll see, there's all my answers. But I have bonus material, videos of me answering the practice problems. They're right here as well. And so I have them as pages, so they're a little bit long. So if you need help with the bottom of page 1, for example, you'll need to fast forward through this and get to the end to get wherever it is. There's the bottom of page 1, and you can hear. Okay, that's nice. Shut up. Thank you. Sorry, it's just embarrassing. You know how it is. You listen to your own voice on a recording. It's like, what? Do I really sound that dorky? Okay, so you will find those things there that you can to enjoy. So hopefully that'll make sense. That's what we're doing. Let's see. The actual test will be similar to the practice test. Let me pull this over to Notability. Open this up. Import. Go. Okay, so here it is, and I think, with the exception of what we have for today, which might just have to be pushed over to the next exam, because I don't have this thing fully typed up. Actually, you know what? We can just tack this on. Yeah, this is all just sequences and series. Are there no power series? No, there's power series. Power series, they're just out of order. Okay, so we're in good shape here. So let's do this. Let's do this. Let me pull this up here just a sec. I need to take a photo of it, and then I'll give you this in just a sec. Take a photo. There it is. Okay, so this is the quiz that I've prepared. So let's just take a look at this and see if we understand how to do it. Because my notation is a little different in the book. Yeah, you don't have to put anything away. I'm not marking this. You can use your friends if you want to. It's probably too late to this. Okay, who needs one? Do you need one? Oh, lovely. Why is it so complicated? That's so weird. And you've got extras. No one is missing. Okay, give me a sec to get this set up, and then we're going to just go over this just as sort of an ancillary or addition, an addendum to the practice test. So, but you can get started on it nonetheless. Okay, there we go. Okay, so let's take a look at this and see if we can understand what the deal is here. The one thing that I felt was lacking from the homework was sort of an understanding of why we care about these things. And the reason why we care about these is because it is convenient at times to be able to express functions as power series, to be able to do things with them. Maybe it's to integrate them or to differentiate them or whatever it is that you're doing. It's convenient. And so there's this classification, this class of functions that are easily converted to power series. And those are the ones that look like a geometric series. So the ones that look like geometric series, those are easy for the most part. Just to remind you how you do this, if you have something that looks like this, 1 over 1 minus, and in keeping with what you saw, the way that Luhmann did this, I'll just put stuff here. That's going to equal the sum where n goes from 0 to infinity of that stuff to the nth power. So the stuff could be x squared, the stuff could be, x plus 2 over 8, whatever the stuff is, that's what this looks like. But not all functions look like this. For example, what about arctan x? What if I want to write the power series representation of arctangent? Well, arctangent certainly doesn't look like this, but its derivative does. Oh. Well, you remember the derivative of arctangent is, or better yet, I could write it this way, that arctangent is the antiderivative of 1 over 1 plus x squared dx. And so the idea behind what you were doing today, which it was kind of opaque, or maybe not opaque, but it just wasn't as transparent as I'd hoped, is that you take a function like this, like arctangent, relate it to one where you can easily write down the power series, and then do whatever it takes to modify that power series to turn it into arctan. So for this one, which is, it's not either of those. So for this one, what I would do is I would say, okay, arctangent of x is 1 over 1 plus, or the integral of 1 over 1 plus x squared. And so that I could rewrite like this, 1 over 1 minus negative x squared dx. Now this looks like that up there, but the stuff is negative x squared. And so this ends up being the integral of the sum, where n goes from 0 to infinity, of negative x squared to the nth power dx. And it might be handy to rewrite that just one more time. Oh, sorry. There. I got confused about what the limits. So those limits are for the summation, not for the integral. So this will be negative 1 to the n times x to the 2n. And now you can all do this antiderivative. I don't need the symbol anymore. So the antiderivative of this is going to be negative 1 to the n times x to the 2n plus 1 over 2n plus 1. And in fact, that is the power series representation for the arctangent. There is this little nitpicky thing that we would have to worry about, and that is what is technically this is arctangent of x plus c, and we'd have to worry about the constant of integration here. I left off that constant, but it turns out that the constant is 0. I think we actually went over this one last time. So up here at the top, what I'm hoping you do is this, that I've kind of given you a hint that the negative natural log of 1 minus x is the antiderivative of 1 over 1 minus, well, x, or in this is the correct notation for this, but if you want to just write it as 1 over 1 minus x, that's fine. So what you're going to do is you're going to rewrite this as a power series, and fortunately for us, this is just the geometric power series. So we have this sum. And then from this, you can actually do that antiderivative. So do the same, so that's for an antiderivative, and then I've got an example here where I'm doing a derivative. So this function doesn't fit our nice, neat geometric power series, but it happens to be the derivative of a known power. In fact, that is the geometric power series. So anyway, write down the, and then just do the derivative for down here. You do the integral up here, and I'll give you a minute, see if you can do this, and then we'll see where we are when we get done. So you can think of this as being an addendum to the practice test. All right, let's see how we're doing here. So I'm doing this the correct way here. However, if you do it like this is really not quite correct. And the reason is that this, because of the plus c business. So it's much better to write this as with limits from 0 to x and use t for your variable. But so I'll try to work through this correctly, even though I'm just as lazy as you guys and don't want to have to write too much, but here I'll do it. So it's relatively simple. You know that the integral of t to the n with respect to t is t to the n plus 1 divided by n plus 1, so that's not too bad. And then let's plug in the limits. So the upper limit, n equals 0 to infinity, of x to the n plus 1 over n plus 1 minus the lower limit. So like I said, this is the correct way to do this, but I forgive you if you just do it this way down here. And then the last thing is to double check what is this series. Well, this is 0, always, right? Because 0 to the n is 0. So that just becomes 0. So the final answer is this, x to the n plus 1 over n plus 1. And if I've done all my math correctly, this is the natural log, or the negative natural log of 1 minus x will be this. Now in terms of the convergence, this will converge for the same place that this thing converges. So this will converge for x between -1 and +1. So as long as x is between negative and +1, this is, whoops, I keep moving this around, that will be the answer for this in terms of a power series. So not too bad. And then down here, you're just differentiating term by term. So let's do that. I'll do it really quick here. You're doing the derivative of this function, which in this case is going to be the sum, where n goes from 0 to infinity, of nx to the n minus 1. And that's it. In terms of convergence, of course, same thing. Since this first one converges, this thing converges between 1 and negative 1 and 1, this one will as well. So these aren't too bad, at least the way that I've got them written, right? Okay, so now that you've got that, let's take a peek at, where is it? Is it here? Yes, here it is. So you might have had a chance to look at the practice test. Let me just walk you through this a little bit. It's a little bit out of order. I pulled a bunch of questions from old exams and just threw them together into this big lump here. And so, you know, there's some repetition as well as some things that, you know, I don't know, are a little out of order, I feel. But one thing to note is, just as with the first half of this, most of the questions that you're going to have on Friday, I will tell you about like what you're going to do. So for example, determine whether each p-series, so hint, use the p-series test. Determine the geometric series. Remember we had that list of all of these different tests. And so I'm going to tell you which one to use. So use a comparison. And I found that the comparison for this one, letter B, was more complicated than I wanted it to be. On the test, it will be a simple comparison. It will be obvious. This one was not so obvious. You can watch the video, you can see, but it was not as obvious. I don't see any here. Oh, it says a comparison method. Oh, I didn't specify. I should have used a limit comparison for this. Wow, I used a direct comparison. This one would have been way easier. I was thinking to myself, why didn't I specify limit? This one would have been easier with a limit comparison. But anyway, so you can, I guess you'll have to decide, do you use a direct comparison or a limit comparison with those? Some of these you'll have a ratio, that one's ratio, and a root, that one's a root. It's pretty obvious, hopefully, that that one is a root method because of that nth power. And this one, whenever you have factorials, probably going to be the ratio method. And then when we get beyond that, almost every series that we're going to encounter from here on out, it's going to be the easiest way that you're going to be to do these is to use the ratio test. So both of these are ratio tests. I suppose you could have, no, you couldn't really use a root test with these. So some ratio test issues here. Write these as a power series. Remember that it's always, with this type of a problem, you're always going to base your function on the geometric series. 1 over 1 minus x is equal to this sum into 0 to infinity of x to the n. So you just have to sort things out and make this look like that. Same thing with this. You can watch the video or just look at my answer key to see how that works. Why? Why is that 3 up there? I wonder how I interpreted that. You know, I think I may have interpreted it like this. Yeah. Otherwise, it's just, well, no, same answer either way. You get the answer as 0, isn't it? But anyway, those some limits. You're going to use L'Hopital's rule for some of those. Okay, so I wanted to mention this. When we get down here, some of this is pretty straightforward. For example, this is geometric, and you use the geometric series formula. This is just the difference of 2 geometric series. So this you can separate into 2 separate geometric series, n equals 0 to infinity of 1/5 to the n plus 1 minus the sum. Okay, I wrote much neater on the practice, on the videos and my answers. But anyway, separate that out. This one, though, what do you do with that? Okay, so what you do with that, I show you in the video, but here, I'll just show you right here, this one, to find the right one. Isn't this? No, that's not ours. That's from Calc 1. Hold on a sec. with alleged answers. There it is. Does this one have the answers? Yes, this one, okay. Okay, so here, this one, pretty straightforward. You're doing and you can hear my commentary if you want to. So this one's straightforward as well, just separated into two. So this one's a series that we didn't go over, but I'll just show you this. And if you don't want to do it, that's fine, because I won't have this actually on the exam. But it's such a cool thing that I need to mention it. This is called the telescoping series. And the way you do a telescoping series, the way you work it, is you write out a bunch of the terms. Technically, I'm cheating here, but you write out a bunch of the terms, and the cheating that I'm doing is that you should be doing partial sums and then figure out the limit of the partial sums, but it's pretty easy to see what's going to happen. That when you write out 1 over 1 minus 1 over 5, 1 over 2 minus 1 over 6, and so on. And if you imagine dropping all of these parentheses, the parentheses are separating each of the terms, term 1, 2, 3, and so on. When you drop all the parentheses, the 1/5 here will cancel with this 1/5, the 1/6 here will cancel with this 1/6, the 1/7 here will cancel with that one, the 1/8 will cancel with the 1/8 that's over here, and so on. So it's like one of these child's toys, like the child's telescope or a telescoping cup that you can get for camping or whatever, that it kind of collapses all down, and all that's left when you get done canceling everything are just these individual fractions. In this case, there would be, if you had a different telescoping series, it would be different, but I added those up, and that's what I got. But like I said, I just wanted to mention that one is not going to be on your actual test. Most of the rest of this stuff should be, but if you do have questions or concerns, I'm happy to answer. And all of the notes that you see here, if you don't understand my notes, what you'll want to do is be like, oh, I don't understand what you wrote there under number 11. What you'll want to do is you'll want to go to the videos. Where are the videos? So find the videos for page 3 and go find number 11.
Okay, so let's take a look at page.
Okay, you can shut up. Okay, so where is number here? I know I can just do this. There. Now you don't have to listen, but you can watch. Where is this number 11 on this page? Maybe it was the next page. Okay, well anyway, I'm blabbing away, talking about this. Look at that, I even put that arrow there. So you can check that out. Okay, so are there other concerns? I know we're only got 3 minutes left, but other things, worries, fears. As always, I will be here at 7:30 if you want to get started that early. One other thing you should note is I just got some notifications. People are signing up for appointments for tomorrow already to visit me. That doesn't mean that you can't just drop in, but if you really want to see me, you might want to sign up for an appointment on the webpage so that you can be sure to get me and not be sent away. All right, I'm going to stop this recording. So if you want to talk to me right now, feel